Look, this is a very hot debate, yeah, among immunologists. There is, I would say, two different schools here. There's one school that comes from mouse immunology, and in the mouse, actually, yeah, there is something like a sequential class switch. So if you start to sensitize a mouse here to develop IgE antibodies, it's usually done by injection or by high doses of inhalation. The mouse develops IgE and IgG antibodies against the same epitopes. In the human, this is not the case, because if the human would produce the IgG antibodies against the same epitopes as IgE, the person would be protected and not be allergic. And the story is that more or less people are very hard, in a hard way, push this idea of the sequential class switch in, I dare to say, very important journals. Yeah? And it's true for the mouse. Yeah? The thing is, we observe or we undertake our investigations in patients, and in the patient it's different. And this is why we have put an emphasis also on this aspect, because as you see in our paper, there is no induction of IgG antibodies, and especially also not against the IgG epitopes. However, it is for the IgE. And that's a very important thing, because if you imagine that the IgG would be pushed against the same epitopes by the seasonal exposure, you would have something like a natural immunotherapy, where you induce blocking IgG antibodies against the IgE epitopes. But this is not the case, because the people become more sensitized after the season. So it's that's one of the reasons why we put a little bit of emphasis on this. It's you can call it an important site observation of the study. I think the major observation, or the really exciting thing is, because there's a hot debate also, yeah, how the IgE response is maintained. There is a paper by Regeneron people, and they say you can target IgE responses in two ways. You kill the plasma cells that are responsible for the continuous IgE production. They do exist, and they produce it continuously. And on the other hand, they try to block the class switch to IgE. What we say now is that there is a basal IgE production, yes, by plasma cells, but in fact, the IgE production stimulated by the allergen comes from the plasmablasts, and this is not, or doesn't seem to be sensitive to blocking the class switch, because it has already occurred. So what we in our model propose is that there is an IgE memory that becomes activated. And what is very important, you can use a monoclonal antibody that exists for the treatment of allergy, and that's omalizumab. It's at the moment used for preventing the binding of IgE to the high affinity receptors on effector cells. What we show is that this antibody, because of this property, can be also used to target the IgE-producing cells. And in that, this antibody has a very unique property that other monoclonal anti-IgE antibodies do not have. The feature of omalizumab is that it does not bind to IgE when it's bound to high or low affinity receptors on cells. So this means that you can shoot exclusively at the IgE-producing cells, but not towards the mast cells, the basophils, and the B cells that contain IgE bound to the high and low affinity receptor of IgE. So you can repurpose this antibody basically for another form of treatment. Yes, this is what we are actually proposing is that this antibody could be used to eliminate such cells, and that could be a very strong bullet in killing IgE responses in patients. And it's different from the idea of the Regeneron people who want to prevent the class switch, because this is something what we think is not so important in the patients. And we also say it's not the plasma cells, because they have a kind of a continuous production that fades away. So we have in the middle what we think is a crucial cell that we can target. The point is, you touch now, I think, a very important topic, because in the seasonal allergy, we would need to shoot at the plasmablasts actually after the allergen contact when these plasmablasts appear. But there is one thing that our paper does not reveal completely, because so far nobody has been able to say whether these IgE plasmablasts come indeed from IgE memory cells. IgE memory cells would contain their IgE as a surface receptor in the same way as the plasmablasts. Now, if this were correct, yeah, what actually nobody could demonstrate because of the very low amounts of such cells, they have never been shown in a convincing way in allergic patients. You could propose to eliminate these IgE memory cells, and then it would be enough here to eliminate IgE memory cells. This is something what our paper cannot say at the moment, because we only show the plasmablasts in the circulation. But we think that the IgE memory B cells in the tissues could be also reached by this antibody. And then the treatment would not be limited to an after-exposure treatment. We think it's universal, because we have seen, this is a birch pollen model that we use. We and others have shown it's also for other seasonal allergens, yeah. And it's surely also valid for perennial allergen sources. However, there you do not have this clear-cut separation of a long time without allergen exposure and the allergen exposure, because people are constantly exposed and boosted. So we think it's a universal mechanism. In our opinion, is a key thing is that there is now a tool of eliminating the memory response eventually. Yeah, of course, this needs to be shown by clinical studies. It is a key thing for us to emphasize again that in the allergic patient, things may be different than in the murine models. So you cannot study everything in the mouse model, yeah, because in the patient, there doesn't seem to be something like a sequential class switch. And our data also provide evidence against the idea that IgG1 producing B cells are the source for the IgE recall response.